Scroll compressors are the most common type of compressor used in commercial air conditioners. But there are subtypes of scroll compressor, which can make things a bit confusing. In this video we will cover the basic operating principle of the scroll compressor and the pros and cons of the fixed speed type. In the next two videos we will discuss the digital scroll compressor and the inverter scroll compressor for comparison. If you don't know much about these scroll compressor types, then hopefully by the end of these videos you will be able to make a more educated decision on what is best for your next HVAC project. So to start with, let's go over the basics of the scroll compressor. Compressors are a vital component of the vapor compression refrigeration cycle. They compress refrigerant and send it around a refrigeration circuit to provide useful heating or cooling to an indoor space. To help explain how scroll compressors work, here is a section view of one. The main parts include the suction inlet, the electric motor, the orbiting scroll, which is driven by the motor, the stationary scroll, and the discharge outlet. The stationary scroll and the orbiting scroll are mated together and form the scroll set. During operation, gaseous refrigerant gets sucked into the compressor and is drawn into the scroll set. Here the interaction between the fixed scroll and the orbiting scroll is what provides the mechanical compression of the refrigerant. The refrigerant enters from the outside of the scroll set and gets squeezed to the centre. From here, the now compressed and hot refrigerant gas exits the compressor from the discharge outlet. Now that we understand the basics of the scroll compressor, the principle of the fixed speed scroll compressor should be pretty self-explanatory. The orbiting scroll is driven by a fixed speed electric motor. This means that the level of refrigerant compression is not variable, and the only way to change the heating or cooling output of the refrigeration system is to turn the compressor on and off. Because of this, a hysteresis thermostat is required to provide temperature control to an indoor space and to meet changes in heating or cooling demand. These work by having acceptable upper and lower temperature limits which tell the compressor when to cycle on and off. For example, let's say a room needs cooling and the desired room temperature is 24 degrees Celsius. Here the upper hysteresis limit could be set to 26 degrees Celsius and the lower to 22 degrees Celsius. This means that the compressor will run and will provide cooling until the room reaches 22 degrees. At this point, the compressor switches off and remains off until the room warms to 26 degrees, where it turns back on again. This process continues for as long as temperature control is required, and the result is an average room temperature which is at the desired set point. But from a real-time point of view, the temperature is always fluctuating. Fixed speed compressors are the simplest and probably the cheapest option that we will discuss in this video series. They do come with some downsides though. Firstly, the unavoidable on and off cycling makes them unsuitable for precision temperature and humidity control applications. Some facilities require a much tighter temperature tolerance than what fixed speed compressors and a hysteresis thermostat can achieve. And for precise humidity control, supply needs to be constantly controlled to a particular dew point temperature, which is not possible with a simple on-off capacity control. Secondly, spikes in current draw can occur upon compressor startup. This can increase the overall energy consumption of the system, particularly if the compressor starts and stops in regular intervals. Suboptimal energy efficiency occurs as a result. And thirdly, units with fixed speed compressors that operate on short on-off cycles are prone to greater wear. This is because short cycling can lead to oil starvation and liquid refrigerant flooding in the compressor, both of which are detrimental to its lifespan. Not only can fixed speed compressors cause wear to themselves, but without soft starting of the motor, the kick they impart on startup can fatigue refrigeration pipework. With excessive compressor start-stop cycling, this can lead to pipework breakage and the loss of refrigerant. Fixed speed compressors are probably good enough for many HVAC applications, but for these reasons, they're not the best option in terms of performance and reliability. Look out for our next videos, which will cover more advanced scroll compressor technologies. And don't forget to check out our website at airchange.com.au.